Hello, everyone. This is Kenneth Wong, Senior Editor for DE 24/7, and usually I'm the moderator for this webcast series. Welcome. Glad to have you on board. Good morning, good afternoon, good evening. I'm not sure what time zone you're in. I'm morning here, but you may be in a different time zone. So welcome. Glad to have you on board. Today's webinar is called Contextual Immersive User Interface, Generative Design, and AI in 3D Experience, CATIA. Just make sure that you're logging on to the right webinar. Now, in a moment, we're going to meet our speaker, but before we begin, let me give you a few tips so that you can get the best possible experience, okay? I want to remind you that if you have questions about today's topic or questions for the panelists, feel free to submit them into the Q&A box at any time. We'll answer as many of them as possible after the presentation during the live Q&A. You'll also be seeing a demo of some of the features, by the way. And for the questions that we cannot get to, I promise you we'll work with the presenters to make sure that you get a written response. You will also be able to download a PDF copy of today's slides and check out some of the resources related to the topic on the resource list, and that should be on the left side of your slide window. Now, if you experience any technical issues and problems, you should visit our webcast help guide by clicking on the help ? Icon. That's usually at the bottom of your console. If the slides are not advancing, you might want to press F5 or hit the keyboard to refresh the browser. That usually solves the problem. First, let's go ahead and meet our presenter today. Danielle, welcome. How are you?
I'm fine, Ken. I'm very fine. I'm very happy to be with you.
Very good. Daniel, would you mind telling us who you are and what you do at Dassault Systems?
Oh, I'm just a CATIA user. I am just, I started 41 years ago CAD/CAM, still using CAD/CAM, and of course CATIA in 1999. So, and I am in charge right now I'm the lucky guy. First of all, I'm located in southeast of France, a nice place in France. But also I'm the lucky guy because I'm visiting a lot of customers all around the world, and I'm trying to get the attention of new capability of CATIA, but also look at the processes, try to understand the processes, and try to show them how we can use, or they can use CATIA the best way to be the most efficient and the more happy.
Very good. Thank you very much. Well, in spite of your busy travel schedule, we're glad that you have made time for us. Today, you're going to be talking about the Smart UI in 3D Experience CATIA and see how it is going to guide our CATIA users through design decisions. So whether somebody is using it for lightweight design or structure and fluid-based topology optimization or parametric shape optimization, I believe the new approach is going to make it quicker and easier to analyze hundreds of designs variations in a very short time. So I'm going to turn the floor over to you, and Danielle, you're up.
Thank you very much, Ken.
Audience, give a couple of seconds. Danielle is going to set up his screen share, and there we are.
Okay, thank you, Ken. Thank you for your patience. So first of all, it's a big pleasure to be with you over the internet. So the agenda of the presentation is very straightforward. It is part. First of all, you have to understand that this presentation is part of a larger presentation called the top 10 values of 3D Experience CATIA mechanical roles, and you will see zoom on some of them. So one of them is a very nice smart user interface that we put into the system. You will see it. We also introduce. You have to understand that we introduce AI since now a couple of years, by the way, and I will show you where we use AI for now. And I will also maybe spend more of my time regarding optimization. Optimization is a key, let's say, technology for you to get faster, to get the best product, the lightest product. And it's really a revolution to help you to accelerate the design and create innovative design. And there will be, of course, probably, I'm sure, monitored by Ken, the conclusion and the question and answer, let's say, topic. Okay, let's go. If I summarize 3D Experience CATIA, it's really best-in-class modeling. it's really to manufacture. So we really think at Dassault Systems that if you design and you do not know what is the manufacturing process that will be actually used to produce the part, you are missing something. And of course, if you know, CATIA will try to help you to take into account the manufacturing constraints at the very, very beginning of your design. You can also capitalize on your know-how and use automation in CATIA. We can manage super large assembly. That's the beauty of 3DEXPERIENCE, by the way. We can, thanks to model-based definition, you can reduce the, let's say, the waste of time due to the production of drawings. You can, by the way, also leverage your assets, your CATIA v5 data, maybe your other system data, the foreign data that you can import in the platform. Validate and optimize your design. This will be one of the biggest topics of today. Manage your processes, manage your data. We are on a platform, database, no file exchange anymore. It's easy to install because you can also use fully on the cloud. So it's easy to install, easy to maintain, it's scalable. You can add any particular new option of CATIA available on your existing install base of software. And of course, and this is also the very first topic I would like to talk, is it's very easy to learn. If you are a CATIA v5 user, you will pick up 3DEXPERIENCE CATIA in less than a couple of hours, okay? And you will understand why just now. So remember, I will focus on best-in-class modeling, manufacturing-ready design, validate and optimize your design, and the easy learning curve and enhance productivity that I will start with. Okay, what does it mean? 3DEXPERIENCE CATIA context-driven menu. It's very simple. Once you pick a geometrical entity in your session, a plane, a contour, a surface, a solid edge, a surface edge, the system, CATIA, will show you what is the most valuable command that you should use after having clicked on this particular entity. This pop-up and this selection of the most recommended action is in fact the result of a question survey that we made with experts on CATIA, and you will see that it's quite cool, and it's really also contextual. And this is what I will show you. So typically on this picture that you see on the lower right corner, if you click on the edge of the solid, CATIA will propose first the edge fillet command, and then on the right of this icon, you will see also point. Maybe you would like to create a point on this edge. Let me show you more in detail what it means. Here, oops, sorry, I was even too fast. But you click on a plane. I will come back. So I click on a plane. You see that CATIA proposed to you, oh, you would like to do a sketch. Now I create my sketch. You will see that even in the sketcher, depending on what you are doing, depending on what you are picking, CATIA will also pop up some comments, the most relevant comment, the most pertinent comment, according to your pick or your selection. Something you might also notice is that if you type in a dimension, just a one click is enough to change the dimension. So in fact, in 3DX CATIA, we reduce drastically the number of clicks, but also, as you can see here, I click a corner. Do you want to do a fillet? Sorry, or a chamfer? And you will just select, okay? So the user is guided. The user will take less time to design the actual same design, but also he will create very quickly what you want to do. And as you can see, there is not that much big dialog box popping up everywhere. We try to focus the session around the 3D, and we focus the attention of the end user around the mouse location to be much more efficient and to drastically, again, reduce the mouse mileage. We reduce the mouse mileage compared, for example, to CATIA v5 by 2. So not only my finger is less, let's say, solicited or excited, but also my hand, my wrinkle is also in better shape, okay? So let's continue. Here you can see that when I click on my edge, sorry, my profile or my contour, CATIA will tell me, would you like to do a pad, which is an extrusion, okay? I say yes. I do my pad. And now if I do, let's say, another sketch, and now I click on the sketch, and now, as you can see, CATIA not only proposes the pad, but also the pocket, because maybe the geometry that you will create by extruding this section or this profile will be used to add material or to remove material. So it's really depending on the context. And this is the beauty of what we call the contextual pop-up or immersive menus. What you see on the middle of the screen, by the way, was just the fact that if you want to have your preferred command, you just hit the space bar and there will be your preferred command, which are located in the so-called action pad. Let's see another example of this contextual behavior. Okay, I am in the sketcher. I create a polyline with 3 lines. It's open, okay, it's not closed. I left the sketcher, and now CATIA will pop up with, oh, maybe you would like to do an extrude. Makes sense. I would like to make an extrude. And I create my extrude. I type in the value of dimension of the extrusion. Okay, and now let's imagine I go back to the sketcher. And I just want to close the contour. It's no longer 3 profile, but it's a square, a closed contour. Now, if I leave the sketcher, the command that will be pop up is no longer only the extrude, but also a fill command, because you can fill a closed contour, but you cannot fill an open contour, okay? So this is the beauty of the UI. And we do that not only in surface design or solid design or wireframe design, but we do that everywhere. So let's have a look on this other example, which are also quite cool, I think. So this is a hull, a boat hull, and I'm just clicking on this curve here. And now I don't want to do a next whatever command which is pop up by CATIA, but I will use this compass. So I will use the first one, which is compass, and I drop the compass on the curve. And now I can see I have 3 different commands that I can do. I will select the first one and select not translate, but offset, okay? And then I move my compass, and then I create an offset curve. And then I can either only create the offset curve, but also create at the same time the surface. Okay, this is quite nice. I can, of course, change the dimension. And if I want to add extra parameters, much more, let's say, advanced parameters to the surface that I created, to the extrude, like I was able to do before, I have a dialog box, I enter extra parameters. So I would say that the classical or the expert in CATIA v5, for example, probably at the beginning, they will use 3DX CATIA like they were used to do CATIA v5. It's the same. And probably smoothly, gradually, they will move to this new UI. And of course, a rookie will automatically use this new UI, which is much more efficient and much more easy to learn. Here, for example, I click on 2 points. And once I create on 2 points, CATIA proposed to me a line. It makes sense. Then I will create a curve here by extracting it. And I want to extract the 2 curves. So I will just propagate with not only a point continuity or a tangent continuity. And once I have that, I have, in fact, 3 curves. Here we are. And by clicking on these 3 curves, I can also create a fill. So this is quite important because users of 3DX are much more efficient and they are guided, okay? That's important. And they are guided by the best commands that have been asked and collected from various experts of CATIA. So the users are even increasing their skill about CATIA. Okay, we also introduced AI in the sketcher of CATIA. The sketcher is the most used command in CATIA everywhere in the world, okay? So what did we do? Let's have a look. This is already available in the product. It's not something which is coming. It's already available. So I go to the sketcher. I create the sketcher, one sketch about this particular road. And there is a command in CATIA called auto constraints. And the auto constraints command, what it does is try to create an ISO constraint sketch and create all the dimension. You can imagine that if you send this drawing of the sketch to the manufacturing people, they will not be happy because it's not really mechanical. It's really based on the solver that we are using. And what the user has to do today, it's not a problem. He has to modify maybe the dimensions, the location to make it more readable, okay? So what we did, we use AI ML, so artificial intelligence, machine learning, and we taught the machine with many sketches, which are much more, let's say, smartly dimensioned and constrained. And now, when you do a sketch like that, if you use the new AI-based command, the result is much more, let's say, conform or compliant to what you were expecting, okay? And so here, if you move from the left side to the right side, it will probably take a couple of, maybe 10 minutes to the user. And in this case, you are winning just 10 minutes in one click, just thanks to AI. And it's the beauty of AI in CATIA. We are using AI to power and to improve the efficiency of the tool to make the user much more efficient. This is really the philosophy of Dassault system. I will show you another AI-based stuff later on in the topology optimization tool, but we also use AI for very simple stuff. It's really available since also 2 years now. You see, in CATIA, we have something called live rendering. So it's a special engine where you can do ray tracing, but live ray tracing. But it can take some time to do that. So you see on the left side of the screen, the computation is ongoing. And on the right side, what we do and what we did is we use AI to upscale the quality of the picture. So what you have on the right is a, let's say, poor quality picture that have been quickly improved in terms of quality thanks to denoiser, which are based on AI as well. So you can get a very nice rendering, an acceptable rendering, much more faster that you are just, if you are just waiting for the CPU to do your job, okay? So here, 2 examples of AI into CATIA. Let's move. Let's continue. Now let's talk about how optimization tools in CATIA can accelerate the design of experiments. Okay, let's start with what you want to do. It's a very simple example. On the left side here, you see a special tooling which is carrying beer bottle in a machine to pack the beer bottle in cartoon, in cardboard. Okay, maybe 3, maybe 6, maybe 12, maybe 24 bottles. And you see in the middle the actual tooling itself, 22 components, almost 5 kilos. So they use what I will show you, our CATIA topology optimization tool. They decided as well to print it. Why not? Most of our customers are doing casting or milling, okay? Some of them, maybe 5%, are using additive manufacturing. But in this particular case, it was 3D printed. They also decided to have a cheaper and not metallic material. So, and they finally get this, what you see here on the lower left corner, a very nice shape, which is lighter, where you can integrate the pressurized air system. And you see here the real part once it has been printed. And you see here the real part in use in the machine. So that's the beauty of optimization. It helps you to create lighter product, cheaper product, as strong a product, and by the way, also cool product, because the look is quite nice, at least for me. Okay, how does it work? You start with specification, boundary, condition, and load as a so-called design space. You start from a geometry, then you optimize it, you get what you see here. Then you create, you do some extra work to convert the optimization result into a good CAD model, and then you validate the CAD model. Every single step that I described here can be done in a 3DEXPERIENCE CATIA with that dedicated app, and you will be not only guided, but it's quite fast. You can, by the way, use our cloud computing capability, so you do not need to have an HPC server or a very big machine in your engineering office. You can use our cloud computing capability, and you will see that it is extremely productive, especially in a stage which is not that much known by people, is to go from optimization to the concept as a cool, clear, clean CAD model. The CATIA is probably the best to be able to do this reconstruction, which is depending on the manufacturing process you are selected, as quickly as possible. Okay, so let's have a look on that. The guidance. Guidance is very simple. We have a very straightforward wizard. Even if you are not an FEA expert, you are just a mechanical designer, like I am. You just select the various stage, you define the parameters, and you get the result. So we have a dedicated user assistant. That's also something which is quite nice. It's straightforward. The learning time is not that big, and it helps you to go faster and to do your design faster. Now, if you go to the performance, you will see that, in fact, we have a lot of capabilities to do optimization. I was talking about 3D topology optimization, but we have also shape optimization, parametric optimization, 2D topology optimization, bed optimization, parametric shape optimization. I will quickly go through all of them. The first one is the most traditional one. So you take an existing part, you define the area you would like to protect and not remove material. You define the boundary condition and the load. Here I will have a virtual bolt with a given stiffness, axial stiffness, and a given shear stiffness. You define the loads. So here it's a remote load at the center of gravity of the 4 drillings, which are in fact the mechanical interfaces with some parts which are besides that. You run the optimization. So CATIA will remove the unnecessary material. Here we are. And now we have this geometry. And now, depending on the process you would like to use, you will have to adapt. You see what CATIA did here is it's no longer a mesh. Huh? It's not something which is smooth, looking like a smooth surface, which is not a smooth surface. Yes, it's a full CAD model. It's not perfect. It's still a concept. Huh? You see, we have to add some edge, some fillet, but it's really a CAD model. You can step out, you can mill it, you can do a drawing, you can also validate by simulation. It's not a mesh. We do that automatically. Nothing to do for the end user. So here we can first validate that everything is fine. The validation by FEA is inside CATIA to do that. And once you do that, maybe we change a parameter. And the parameter that I change, I only change one parameter. I say, okay, now I know what process I would like to do the manufacturing. I will use casting, and I define the pulling direction. And this is the shape that I got. Or maybe I would like to do milling. I gave the 3-axis direction of my milling machine, if it's a 3-axis milling machine. This is the result that I get. I can also validate. I can also do additive manufacturing. I define the printing direction, the famous angle for the support for the 40 degrees, 45 degrees. CATIA will try to make a geometry which is self-supported. No need for support when it can, when it is possible. And then I can also compare with a trade-off, which one is the best, depending on, of course, the cost, maybe also depending on how many parts I would like to produce. If it's one part, additive manufacturing is the cheapest. If I want 1,000 part, milling is the cheapest. And if I want 1 million, I will probably use a tool like casting or plastic injection molding. Okay. Something which is also cool in 3DX CATIA is that if I decide to go for milling, I have a dedicated wizard. It's patented. We put a patent on that. And it look at the 3 direction of the milling table, compute the silhouette, and the silhouette is created as a sketch. And we are using AI to approximate those silhouettes, especially for the pocket, which are polyline, into valuable sketch made of maybe a circle, maybe an oblong, maybe a square with some fillet or any polyline contour. And this is automatically done with AI, because we also taught the machine. We give the machine a lot of profiles, and now the user is no longer forced to approximate or recognize himself the type of profile. The machine is doing that for that, thanks to AI inside CATIA. And finally, you get the geometry, you get the final model, and you can, of course, if it's additive manufacturing, you can continue to improve it, run a simulation, and compare. Okay. Now that this is done, we can do shape optimization. Let's say now I decided to go after my additive manufacturing product, not the milling one. So I have my part, but I computed the stress, and there are some areas which have excess of peak of stress. It's not acceptable, okay? So what I do, I isolate the area where I would like to remove the peak of stress. So this is my dark gray area that you will see on the screen. And now I will optimize only the shape, mainly, typically the fillet area. I bump them a little bit to remove the peak of stress. And it's a similar tool inside CATIA to do not only topology optimization, but local shape optimization to remove peak of stress and to be sure that the part, once in service, will behave as expected. You see that we reduce drastically the peak of stress. But we also do parametric optimization. Now I go back to my solid model that I created for being milled, okay? So the beauty of the platform and 3DX is we can use design of experiments, and it's called in CATIA and our 3DX parametric design study. How does it work? Now it works, you start with a parametric model, okay? The one I created with my milling assistant. And now I will say, okay, let's do multiple parameters. you define the connection and the loads, and now you want to lightweight the part that was already lightweighted by the topology optimization. So you already define your load cases and boundary condition, and CATIA will now run a parametric design study. You decide which variable should be used to compute the various variants. Here I selected 3 variables. You select the minimum value of the range, the maximum value, the step between two ranges. You select, of course, the response variable, and then CATIA compute all the samples, what we call points, all the variants of each parameter change, and then it compute a simulation. So in this particular case, a structural analysis. And then I get the optimal, either I take the optimal solution, or I select some of them and I compare them to see which one is the best. And this is the over-optimized part in terms of weight. Why we do that? Because typically when you are reconstructing a model, the human being always add material. It does not remove. It goes over, not under. So by reconstructing the model, he extend a little bit or he increase a little bit the weight. And this is a way to really go back to an optimal weighting. And by the way, we do also the same, not only on massive part, like the one I showed you, but we can also work on sheet metal design part. So you design a sheet metal part in CATIA. You can see that it is sheet metal because you can at any time unfold it. Okay, it's a feature of CATIA sheet metal design. And now I will try to optimize the weight of this satellite casing, micro satellite casing. Complex boundary condition and laws, but it takes into account the context. And you will now improve the weight by just removing unnecessary material. And the good news is that it's still a sheet metal design part, so you can also have at any time the unfolded view, which is the one which will be used for the manufacturing in the shop floor of this particular casing. And what is done on sheet metal design is also possible on just surface design. If you use our generative shape design surface design tool, you can do the same. And you can also not only reduce the weight, but you can also optimize the position of the beads. So let's say I have a sheet metal part. I define the area where I would like the bead to be created, to the stiffener if you prefer. You define the boundary condition, you define the load. Now it's no longer a tetrahedral mesh, but a shell mesh. Because as you know, on the sheet metal part, the thickness of the metal is constant. And then CATIA find for you the area where you should put a stiffener. It will also tell you how much is the depth of the stiffener. Here we are. It recreates the depth. It recreates the stamps on the sheet metal part, and you can then compute again validate the 2 parts to check which one is the stiffer, but also the lighter. So topology optimization on solid part, on surfacing part, and something very new, we introduced it in February this year. It's called parametric shape optimization, okay? Maybe I will have to go first to explain to you what is parametric shape optimization. It's a patent, it's a unique technology that it belongs to Dassault System. We have parametric optimization, I showed you. We have non-parametric optimization, topology optimization, but we have also now introduced this one. What does it do? It starts from a parametric model, not design space, but a parametric model. It preserves the geometric feature and constraints. It's almost like a parametric optimization, but the difference is that it is based on a fast sensitivity optimization. In fact, it computes the gradient of evolution of the parameters, and is never remesh for every single variant of your design. And therefore, it can handle large number of variables. Okay, so it's like parametric optimization, but with a different technique, which allow to take a lot of design variables compared to the classical world. And the beauty of that is that, when people are doing a parametric optimization, they have to do a choice. They have to select the 1, 2, 3, 4, 5, maybe 6 different critical parameters, but maybe they are missing the most important. Thanks to parametric shape optimization, you give 200 parameters to the machine, and then the machine will automatically find out the most critical one, so you can converge much more quickly, but you can also be sure that you are really optimizing what needs to be optimized. Okay. Let's go back to this video. So I have my crane. Here we are. The crane of this excavator. This is a parametric model. I define first a solid, which is because you define what you want to change, but also where you want to change, which is a solid design, which was in green, okay? And now you run the parametric optimization. Of course, you have to define boundary condition, loads. You see all the design variables here? We have many of them. You define, of course, the response variable, what you would like to optimize. CATIA first compute everything to be sure that you have something which is acceptable. And then he optimizes all the parameters of the parametric design model to achieve the target in terms of von Mises stresses or maximum displacement or weight, which is typically the most important. Okay, stiffness and weight are important. Now let's take another example. It's a hull of a boat. We have also many parameters. We'd like to optimize the thickness of all those ribs. Define the response variable, and then CATIA will also perform the optimization thanks to parametric shape optimization. And this one I like very much. Let's say you have a part which has been topology optimized, and you reconstruct a nice, or you smooth the result of the topology optimization by creating a subdivision surface. And as you know, subdivision surfaces are managed by the so-called base mesh. But now you would like to further gain weight on your topology optimized model for example, additive manufacture, and you will ask parametric shape optimization to optimize the position of the base mesh to reduce the weight, but still keep the stiffness of the part. So here I have 200 variables, and it's extremely fast to compute and optimize the position of all those base mesh points to reduce the weight of this already topology optimized part. Okay, that's the beauty of what we do. By the way, we are not only structural analysis based, we are also doing fluidic optimization. So in this particular case, it's an air intake system. I will start by doing my topology optimization based on fluidic. I define the velocity of the inlet, at the inlet of the fluid. I define the expected pressure at the outlet, and then I compute the optimal vein of my shape. What CATIA is doing is just eliminating in the vein, the initial vein, the area which are creating turbulences, and therefore it will optimize the pressure drop. Here you can see the fluid circulation. We can even add some filter, so we'll take also in and or out, or both, and it will take into account the porosity of those filters. And at the end, I have my vein, and what I want to do is I want to optimize the weight of the casing of the vein. So let's start with a classical casing, which is constant thickness everywhere. So now I run my topology optimization. I know the pressure of the fluid inside the vein. I know maybe how the part is fixed or fastened to other parts. And then this is what CATIA is creating for you, is creating a lot of the ideal position of the ribs, because I decided to have a plastic injected part. And then you can compare the initial part, the one with ribs, and so on and so on. Okay. So we can do multi-physics optimization in 3DEXPERIENCE CATIA. So let's finish by some simple stuff, but you see here the trade-off study helps you to make the right decision. You can define your own KPI. You can define the priority of your KPI. Maybe weight is more important than max displacement, or maybe more important than von Mises stresses. You can also select new shape. You will see the productivity of the tool is quite good to reconstruct the model. We support plastic injection molding, stamping, casting, forging, milling, additive, as I mentioned earlier. And I already showed you that if you decide to go after 2.5 or 3-axis milling, we have this AI-based patent to just recognize all those profiles and automatically create sketches to be able for you maybe to later on modify and optimize further if you use parametric design study or parametric shape design optimization. You can also gain extra weight. You can also do the same on sheet metal. And again, something which is important, it's not only sheet metal design part, but also surface part, fully surface part, like a body-in-white structure, for example. And something which is quite new, it's we introduce also a tool to help you to reconstruct a cast part. A lot of customers of us are asking are using our topology optimization to do cast part, because it's probably not a small serial of parts they want to produce, but a big serial of parts, and casting is good for that. Let's take a part. This is the part that I would like to optimize. No problem. It's the same process. I will not go through everything. It's exactly the same process, but I selected, of course, the pulling direction and of the draw. And now what CATIA is doing is trying to help as much as you can the end user to reconstruct a usable CAD model, which will be used for the foundry process. So it creates various polyline and converts those polyline thanks to the AI machine learning technology, which has been embedded in this profile recognition. And it creates also a smooth geometry, and it projects the smooth geometry to the top of the part. And you see here what is created very quickly is a very nice part, and it takes a couple of, let's say, less than 1 hour to do it. If you have to do it today, you can probably count around 3 or 4 days. Okay? And something I like very much as well, it's the fact that now we are also automatically reconstructed the rib. Okay, so let's see how it works. It's quite cool too. It's almost my last slide. So you take the part, you optimize the parts. You know that. I have multiple ribs. The ribs are just polyhedra. Okay. So what we do is we have a special wizard. He will compute the center line of all those ribs. He will then compute, let's say, exact rib definition. Again, the same AI tool is used to approximate the polyline, which is the center line of this concept ribs, and create, let's say, canonical sketches, polyline or made of segment, arc of circle, and then it creates automatically the ribs for you with a given thickness. It's important because most of the time, what they do, people, when they do such stuff, they create ribs like that. They have no idea where to put the ribs. So most of the time, the part is much more heavy than what you expect. Here, it's really where you need to put the ribs. Okay, so you are sure about the optimal solution that you get, and this is the final job. And again, I can do such a job very, very quickly. If you have to do that manually, I can tell you it takes a lot of time. Finally, last presentation. Let's discuss with a customer of us. He uses our tool since a long, long time now, almost 4 years. And it's in French, but there is an English subtitle, okay?
En tant que designer, du coup, ça me permet d'obtenir des formes performantes aussi, parce qu'il y a l'allègement de matière, mais c'est aussi des structures qui sont performantes. Et la performance, c'est beau.
Bonjour Fabien, j'espère que vous allez bien. Est-ce que vous pourriez commencer par vous présenter?
Bonjour Daniel, alors je m'appelle Fabien Chancel, je suis designer et j'ai découvert les outils de la simulation assez récemment.
Quelles sont les solutions logicielles que vous utilisez pour faire modélisation et simulation?
Alors en tant que designer, je cherchais en tout cas à mieux définir en tout cas et répondre à des cahiers des charges qui étaient assez complexes dans le milieu de l'innovation. Et donc je faisais du CATIA pour la modélisation. Et ensuite, je me suis intéressé en tout cas à d'autres outils que j'ai découverts à travers la simulation pour de la mécanique des fluides, pour du thermique. Et cet outil, c'est donc Simulia.
D'accord, donc vous utilisez à la fois CATIA et Simulia. Est-ce que la partie optimisation topologique, on appelle ça Generative Design dans CATIA, c'est quelque chose que vous avez, que vous utilisez et qui vous intéresse?
Alors c'est l'une de mes utilisations préférées.
D'accord.
Pourquoi? Parce que quand on veut répondre à des contraintes mécaniques, on a tout de suite en tout cas une réponse juste donnée par la simulation. Et c'est la simulation, en termes de méthode de travail, c'est ce que je mets en premier lieu dans les premières démarches, c'est-à-dire pour vraiment dimensionner, savoir où on se situe en tout cas par rapport à des solutions auxquelles on souhaite répondre. Et la modélisation finalement est revenue après. CATIA, par sa robustesse, la modélisation en deuxième, quand on veut que ça devienne un objet réel.
Alors c'est quoi les avantages d'avoir une solution qui unifie la modélisation et la simulation?
Alors les avantages en tout cas, pour moi ils sont nombreux. La première c'est que sur une même plateforme, je peux passer d'un outil à l'autre sans me rendre compte en tout cas que j'avais changé d'atelier. Voilà, j'ai l'atelier simulation, l'atelier modélisation, l'atelier ergonomie et quelque part ce qui est génial c'est que dès qu'il y a une nouvelle application qui sort, on peut l'utiliser tout de suite sur une même plateforme. Donc c'est très transparent, on s'aperçoit même pas en fait qu'on change d'outil quelque part, on reste vraiment dans le même environnement.
Et vous parliez de la robustesse de CATIA. Est-ce qu'il y a d'autres choses dans CATIA que vous aimez bien? L'aspect paramétrage, l'aspect par exemple optimisation topologique pour faire de l'allègement de matière. Est-ce que c'est important l'allègement de matière pour vous?
L'allègement de matière, c'est une problématique actuelle. On cherche toujours à faire les pièces les plus légères qui consomment le moins de matière possible. Donc je l'utilise systématiquement parce que on commence tout de suite avec ce qui est le plus performant.
Naturellement, vous utilisez pratiquement tout le temps par défaut l'optimisation topologique.
Tout le temps.
Ce qu'on appelle dans CATIA le Generative Design.
En tant que designer, du coup, ça me permet d'obtenir des formes performantes aussi, parce qu'il y a l'allègement de matière, mais c'est aussi des structures qui sont performantes, et la performance, c'est beau.
Fabien, est-ce que vous pourriez nous dire sur quel projet vous êtes en train de travailler actuellement?
Je te présente un concept.
Oui.
Alors j'ai toujours rêvé de faire Paris-Lausanne en 1 heure. Et avec le moins d'émissions de carbone possible. Pour la surface extérieure, là ça reste du classic design, c'est-à-dire vraiment on va dessiner la forme, mais je l'ai dessiné bien après, presque en dernier. J'ai conçu un châssis, on va récupérer des vraies tailles de roues, et à partir de là on peut commencer à concevoir, alors pour le coup un nouveau châssis qui serait lui aussi plutôt léger, après avoir conçu un châssis, après avoir positionné des humains dessus, avec la meilleure ergonomie possible. Et à partir de là, je vais faire de la simulation, donc du generative design, de l'optimisation topologique, pour être précis. D'abord, commencer par dessiner un humain qui est plutôt bien installé. Ici, donc, tu as les résultats bruts d'une simulation où j'ai demandé à Katia, est-ce que tu pourrais m'aider à dessiner un siège et avoir un siège le plus léger possible. Une fois qu'on a ça, je peux très rapidement concevoir un siège, c'est-à-dire avec ses accoudoirs, avec un dossier qui est molletonné, et on va s'approcher de la course automobile. Parce que si on est trop léger, la voiture va s'envoler, n'est-ce pas? Donc il y aura tout un travail après d'aérodynamisme pour être sûr que le véhicule puisse faire mieux qu'Hyperloop avec beaucoup moins d'infrastructures.
Mais dites-moi, est-ce que vous aviez au départ un profil de spécialiste éléments finis, de calculeux quoi?
Alors absolument pas. Moi je suis designer, c'est-à-dire designer, tout ce qui est plus classique quelque part. En fait, sur Simulia, en tout cas l'accès à la simulation, elle m'a paru facile. Il faut s'entourer un peu de quelques experts quand même pour pas commencer tout seul. J'ai pu rentrer dans le calcul d'éléments finis de manière assez simple.
Donc vous faites pratiquement que du generative design, vous utilisez tous les avantages de la simulation intégrée, vous commencez par la simulation, l'allègement est important pour vous. Alors ça va être quoi la prochaine étape? Qu'est-ce que vous verriez faire dans le futur?
Dans le futur? Oh là là, j'aimerais discuter avec Katia. Pour que dans la simulation, en fait, que ça soit pas que souris, écran, moi j'aimerais beaucoup discuter avec mon simulateur pour poser des questions et d'avoir tout de suite un peu des premiers résultats, des premières briques, mieux gérer mon environnement aussi de stockage de données. J'aimerais que ça soit plus un dialogue oral avec Katia.
Alors, comme les Anglais disent, stay tuned. Je ne peux pas vous en dire trop maintenant, mais sachez que ça va arriver bientôt. En tout cas, merci beaucoup Fabien, c'était un plaisir d'être avec vous ces quelques minutes.
Oui.
Bonne journée et à la prochaine. Et continuez à utiliser CATIA Simulia, ce qu'on appelle nous le mode sim.
I just want to conclude by just what you saw. You saw a little bit of 3DEXPERIENCE CATIA, which is a best-in-class modeling, how we integrate the manufacturing constraints in the very beginning, how you can optimize your design very easily, and how you can also learn the product very quickly. And now I leave the floor to Kenneth.
Very good. Welcome back, and we're going to do the Q&A together. So, by the way, we already have a lot of questions. Some of the questions came in during our registration from people who are registering. So let me go ahead and start with some of the questions that we received, Danielle, from the audience. Okay. All right. And then remember to get out from the screen share, and then you'll be back with me on screen here. So the first question that I receive is, what's a interrelationship between design of experiment and generative design? Does 3DEXPERIENCE develop an algorithm to interface between these tools so they somehow automatically support each other? That's the essence of the question. Daniel, what do you think? What are your thoughts on that?
Yeah, Yeah, I think hopefully you saw what I showed. Either you use a design of experiment with our tool called parametric design study, standalone, and you get an optimized parametric model, or you want to really reduce lightweight in some area which are unknown for you, so you use topology optimization, and from the topology optimization result, you can create a parametric model, which is now can be used by parametric design study. So you can combine both.
Very good. And another question following this up, somebody wants to know what's included, the components of the simulation that is in the optimization, I guess. For example, thermal, vibration, what's included? Can you say?
Yeah, today we do structural analysis. By the way, we are using our Abacus solver to do that. We do also fluidic. We are also using the fluidic aspect of Abacus. We are not for now running thermal optimization, neither vibration. We still compute the minimum eigenvalue frequency, okay, but it's not really vibration. But we already have our engine. We are using Tosca for the engine of topology optimization. Tosca itself can now do also thermal optimization. So probably in the next releases of CATIA, we might also address the thermal topology optimization.
All right, very good. There's another question. It goes, is this AI and generative design features available in next CATIA, or is it available as a kind of a plugin?
It's not a plugin. Huh? Our idea is we use AI not to give you AI. We use AI as a middleware and to develop new or improve our existing command to take benefit of AI. So we are developing AI. Like what I showed you is that we are able to recognize multiple profiles which are polyline into a sketch, arc of circles, segment, spline. It's time consuming to do this recognition of polyline, and we use AI to help to speed up this recognition. So we really use AI as middleware, and which means that it's not a plugin for you. Huh? It's included, it's inclusive with 3DEXPERIENCE CATIA. It will not be the same for every single AI-based solution that we'll put on the market that we call the AI generative experience. But so far, and we're already there in 3DEX CATIA, and we will continue to add extra other AI-based solution. Again, our goal is to satisfy our customer, to make them more efficient and develop their product in the shortest possible way.
All right. The next two questions, I think you have already answered in your demonstration, but I'll give it to you and see if you want to add something else. How does generative design features and contextual immersive user interface, how do they affect the product development workflows?
Yeah, if I start by the smart UI, you see that you are guided. The user is proposed to use the most pertinent or the most relevant command after a click on the screen. So it helps you not only to improve your design skills in CATIA, but also to make the best product by using the right tool at the right moment. And generative design is typically a tool to optimize. You can reduce the weight, as I showed you. You can optimize the pressure drop of a duct. So it's a combination, but all those tools, the goal of all those tools is to make you more efficient.
Yes. Next question. Does generative design AI help you convert 2D drawings into 3D models? Does this need any FEA solver to optimize the geometry based on FEA analysis results? What do you say to that?
Okay, you saw that. Yeah, you saw that topology optimization, parametric shape optimization, parametric optimization. All of them are based on FEA, structural or fluidic. Okay, you are not forced to use it. For example, you can use parametric optimization to optimize or to define the shape which will target a given volume. Okay, because maybe you are designing bottle or package and you want to reach 1 liter of content, and you don't know which parameter you should modify to get this target. So you can use parametric optimization, not topology optimization, but parametric optimization without any FEA. But most of the time it's based on FEA, because what you want to do to get is a reduce of the weight, a max displacement, a certain eigenvalue of frequency and stuff like that.
That's right, because FEA is helping you understand where the stresses are,
Yeah.
right? So you can know where you can remove the materials. Okay.
Yeah.
Another question, I don't know if you really want to take it. It's a comparison question. How would you compare yourself to ANSYS, MATLAB, etc.? Do you have the ability to include metadata or some other means to link the design architecture and constraint to a system requirement document?
Yeah, for that, we will more talk about the platform. Today, in the platform, in 3DEXPERIENCE, we have a requirement management. Those requirements are managed by the platform. More than that, those requirements can be attached to a design parameter in the CATIA modeler. So if, for example, you want to have a particular nice shape between two body panels because it's a premium car, and the shape, the gap between the two shapes must be very, very parallel, this has an impact on the design itself, but also on the manufacturing itself, and the stamping and the assembling and the welding. So we take into account that. That's the beauty of the platform. So we are also able, by the way, to do system engineering. So we have MATLAB type of capability. We are able to also import MATLAB through Simulink data or FMI standard. So yes, we manage simulation, we manage specification, we manage design, we manage manufacturing, and this is extremely important. So the platform does that today. It was even developed for that since the very beginning.
All right. Danielle, also, there are some questions that came in from the live audience. I'm going to give you a chance to browse through them. And essentially, question 11 through question 46 are the ones that came in while you were presenting. So take a look at them and see if there are some of the things that you want to address. If you want to address them, tell me the number, and then we'll go by the number. In the meantime, audience, let me just remind to you that, after this, you are able to download the PDF copy of the slides that Danielle has shared. So this will be a great resource to you. Danielle, go ahead. Which question you would like to take?
Yeah, I take the question 46 because it's the first one which popped up.
All right, very good. Let me read the question. Does the generative AI for design and simulation solution use the existing customer data to perform? Well, that's actually a very important thing that customers want to know. Go ahead.
Yes. So you know that AI, typically, let's take ChatGPT. ChatGPT is using all the data which is available on the web. So maybe some data that ChatGPT is using is not protected by the owner of the document. We don't want to do that. Okay, we want to take care of the intellectual property of every single company. So we are today putting on the market. It's not so far in CATIA, but it's in Simulia. We are able to use AI, teach the machine how the part of a given customer are designed, and take some and let's say deduct from those various parts a surrogate model that will be used to speed up for a new part which is coming. It has been defined, a new part to be optimized thanks to AI. So for that, we will not ourselves use the data because we will use the data of the customer, but the data of the customer are not seen by us, are seen by the machine, and will give them the result. It will be their intellectual property. It's very important. AI should be under the control of the customer. That's very important, and we take care of that. By the way, we have now our own ChatGPT, which is coming in a couple of weeks. It's called Aura, and Aura today is just using the Dassault system document and information which is in our network. Okay, but some information is helpful for you because it's just the documentation, online documentation, best practice about using CATIA done by university, which is public. But we really want to protect the information, which is in fact a golden mine for every single customer.
Very good. Danielle, I'm afraid we are running down the clock and we are approaching the end of the hour. So I think we may have to end here, but I promise you audiences, your questions will be collected and sent to Daniel and his team so that he's going to respond to you in writing for all the questions that you have. In the meantime, I'd like to thank Daniel for the opportunity to co-present the new features and context-sensitive contextual menu and AI-driven features in CATIA. And I'm Kenneth Wong. I'm Senior Editor for DE247, and we want to thank the sponsor, Dassault Systems, for making this live discussion possible. And I also want to thank you, ladies and gentlemen, for spending your afternoon or morning or evening, whatever that may be, with us. I appreciate your time. I also want to thank the invisible webcast producer, Steve Paul, who worked behind the scene very hard to make us all look good, sound good, and everything goes smoothly. And today's webcast has been a pleasure. Ladies and gentlemen, until next time, I'm Kenneth Wong, and we are out.
Bye-bye.